A few days ago, the United States government made history when it did something the world never thought it would. The Pentagon released what it calls never before seen files on UFOs. There were videos, photos, and classified military reports spanning back decades, even to the moon landing. All of it posted publicly online for the first time in human history. No clearance required. The internet absolutely exploded in many different directions, but that's not what we're here to cover today. And here's the thing, buried under all of the noise, all of the headlines, and all of the social media speculation, there is an actual scientific question sitting at the center of all of it. Not, did the government cover up the aliens? Not, what is that thing in the video? The real question, the one scientists have been wrestling with for decades, the one that keeps some of the sharpest minds on Earth up at night, can alien life actually exist? Because here's what nobody's saying in all of the UFO coverage right now. Science already has an answer to that question, and it's more interesting than anything in those files. Let's start with the files themselves, because if you're watching this thinking the government just confirmed alien life, you need to hear this first. The released files show no indication that the United States government had any interaction with beings from other planets, or that it has any reason to believe such beings have actually visited Earth, let alone that the government covered them up. That's not a conspiracy, that's what the files actually say. Sean Kirkpatrick, the first director of the Pentagon's All Domain Anomaly Resolution Office, agency specifically created to investigate these sightings, told CBS News that people expecting evidence of alien life here on Earth may be disappointed. There are going to be unsatisfied people, he said. You're going to have a bunch of people who are going to continue to cry conspiracy. What the files do contain is genuinely interesting, though, and genuinely unexplained by what we know. Reports of metallic elliptical objects floating in midair, orbs launched over other orbs in the western United States, which the Pentagon itself calls among the most compelling reports it holds. A mysterious craft observed zipping across military surveillance systems in Iraq at a high rate of speed. Sightings spanning from the Cold War Germany all the way to Africa in 2025. But let's be a little more clear here. This is what unexplained actually means scientifically. It means we don't know what it is. It does not mean we know what it isn't. Harvard physicist Avi Loeb, one of the most prominent researchers in this field, said that in most instances of unidentified phenomena, something mundane might explain the data. Unexplained is not the same as extraterrestrial. So let's set those files aside for a moment and let's ask the real question, the one science can actually speak about. In a universe this size, can life exist somewhere other than the Earth you're on right now? Before we get to the science of whether life can exist elsewhere, you need to understand the scale of what elsewhere actually means. There are more stars in the observable universe than there are grains of sand on every beach and desert on Earth. Let that number sit in for a second. Thanks to discoveries from Kepler's space mission, we now have statistical evidence that essentially every star has one or more planets. When you look up at the night sky, there are actually more unseen exoplanets there than there are stars. Every star, a planet. Every one of those points of light, at minimum, a solar system. Today, more than 5,000 exoplanets are confirmed, and their number continuously grows as we observe more. And of the thousands, a meaningful fraction sit in what scientists call the habitable zone, the band of distance from a star where liquid water could exist on a planet's surface. Now, here's where it gets a little interesting. In 1961, an astronomer named Frank Drake sat down and tried to calculate the odds. He created what has become known as the Drake equation, a formula that multiplied together all the factors needed to produce an intelligent, communicating civilization in our galaxy. Drake himself estimated perhaps 10,000 communicating extraterrestrial civilizations might exist in the Milky Way alone. But other people's estimates using the same equation have been wildly different. From just one civilization, us, to millions. Why is there such a wide range? Well, actually, we know the answer to that, because several of the variables in the equation, we genuinely have no idea what these numbers should be. Some of the terms have literally no idea what their numerical value should be, said Michael Wong, a planetary scientist at the Carnegie Institution for Science. Here's what a recent NASA published paper concluded. Unless the odds of advanced life evolving on a habitable planet are astonishingly low, humankind is not the universe's first tech civilization. The paper showed that even with the most pessimistic estimates, the sheer number of exoplanets makes it statistically difficult to argue we are alone. That's statistically difficult. That's not science fiction. That's a paper published in a journal, Astrobiology. Here's where the science gets genuinely interesting, though, because for decades we've been asking the wrong question. We've been asking what planets are exactly like Earth. The better question is, what does life actually need to survive? And the answer, based on what we found right here on our own planet, is far less than we ever thought. There are organisms on Earth that survive in areas of extreme temperatures and pressures, where it's really acidic or not acidic at all, where it's super salty, where it's really dry, with lots of radiation, and even in places where the chemistry would be toxic for humans to live. We call them extremophiles, and they have completely rewritten the rules from where life can exist. Microbes thriving in boiling water around deep sea hydrothermal vents, no sunlight, crushing pressure, temperatures that could cook any human alive, bacteria surviving inside of nuclear reactor cooling pools, organisms frozen in Antarctic ice for hundreds of thousands of years and coming back to life when thawed. Tardigrades, microscopic animals that have survived the vacuum of outer space. The presence of extremophiles on Earth suggests that the true habitable zone of a star system is far larger and more diverse than we thought. It could include worlds with vast subsurface oceans kept liquid by tidal forces, like Jupiter's moon Europa, and it could be high and acidic clouds of a planet like Venus. This is the part that changed everything for scientists searching for life elsewhere. Because if life doesn't need a perfect Earth-like surface, it can survive in conditions we once thought were completely hostile. Then the number of potentially habitable environments in our solar system alone multiplies dramatically. Europa and Enceladus have gained enormous attention over the last few decades due to the existence of internal liquid water oceans beneath their frozen surfaces. Enceladus, one of Saturn's moons, is actively venting water vapor and hydrogen from cracks in its ice. This suggests ongoing hydrothermal activity and thermodynamic disequilibrium in its subsurface ice-covered ocean. The implication being that chemolithotropic microorganisms, microbes that use inorganic chemicals for energy, might inhabit this deep alien ocean. On Earth, entire ecosystems exist around hydrothermal vents on the ocean floor. No sunlight, no photosynthesis, just chemical energy. Thriving, complex, and very much alive. If that's possible here, in the complete darkness at the bottom of the ocean, why not in the oceans beneath Enceladus's ice, or Europa's, right now in our solar system? We currently have missions going there to find out. In 2025, something happened that set the scientific community on fire. 120 light years from Earth, a planet called K2-18b orbits a star in the habitable zone. It's bigger than Earth, but smaller than Neptune. And based on everything we can observe, it may be a world entirely covered by deep ocean. The James Webb Space Telescope pointed at it and analyzed the light filtering through its atmosphere. Researchers reported detecting methane and carbon dioxide, and intriguingly, they also saw hints of dimethyl sulfide. The sulfur-based molecule is seen as a potential indicator of life because on Earth it's only made by living things, such as ocean phytoplankton. The headlines erupted. Signs of life on alien planet, trending worldwide. Here's what the science actually says, though, and this is where the video needs to be honest, because this is where most coverage sort of failed. An independent analysis concluded that the red noise, rather than an astrophysical sign, plagues the mid-infrared data, and there is, as yet, no statistical significant evidence for biosignatures in the atmosphere of K2-18b. Signals from K2-18b have been misidentified before, years before actually. Researchers found signs of water vapor using Hubble. It later turned out these signals were caused by methane. Decoding the atmosphere of a faraway planet is a complicated task. So, is it life? Honestly, we don't really know yet. The data is contested. Scientists are debating it actively right now. More observations are coming. But here's the thing. The fact that this conversation is even happening, that we have a telescope powerful enough to analyze the atmosphere of a planet 120 light years away and look for the chemical signatures of biological activity, that is extraordinary in itself. We are currently poised to be able to make a meaningful statement about whether or not other life is out there in the next decade. The James Webb Space Telescope allows us to point directionally at a potentially uninhabited planet and study its atmosphere for biosignatures. We are not waiting for aliens to show up anymore. We are going to them, one spectrum at a time. So, if the universe is this vast, if life is this resilient, if habitable environments exist in our own solar system, where is everyone? That question was first asked out loud by physicist Enrico Fermi in 1950 over lunch, casually, and it became one of the most disturbing, unsolved problems in science. The Fermi Paradox. If the probability of life is high and the universe is 13.8 billion years old, then statistically, advanced civilizations should have had billions of years to spread across the galaxy. We should see signs of them everywhere. Radio signatures, megastructures, something. But we see nothing. Several serious scientific explanations exist on this matter. None of them are very comforting. The first is the great filter, the idea that somewhere on the journey from simple chemistry to spacefaring civilization, there is a step so difficult, so improbable, that almost nothing survives it. The terrifying version of this theory is that the filler isn't behind us, but actually what lies ahead. The second is that we're not looking right. Our SETI searches have covered a tiny fraction of the possible frequencies and star systems that could be broadcasting. We've been listening for radio waves for about 60 years in a galaxy 100,000 light years across that is 13 billion years old. SETI is now exploring more stars at a wider range of frequencies than ever thanks to the Breakthrough Listen initiative, the most comprehensive search for extraterrestrial intelligence ever conducted. The third is the universe is producing life right now, but most of it is microbial, simple, not broadcasting anything. The conversation has shifted to the search for life that is not necessarily intelligent, something that Earth's own history would tell us is much more likely to find. For 3.5 billion years, of the 4 billion years life has existed on Earth, it was nothing but single-celled organisms. If you compressed Earth's history into a 24-hour clock, multicellular life didn't appear until 9 p.m. Humans showed up at 11:59. The universe may be full of life that will never make a radio broadcast, that will never build a spaceship, that is just alive somewhere in an ocean under some ice doing what microbes do, and we would never know. So, what do we get from all of this? Do aliens actually exist? Here's what science can actually say right now as of 2026. The mathematical probability, based on the number of stars, the number of exoplanets, the resilience of life, the age of the universe, strongly suggests that we are not alone. As one scientist puts it, the possibility of other alien life existing is very likely, but it doesn't mean it's near us. The government files released, they show no indication of extraterrestrial contact, but they do confirm something important, that the government itself considers this worth investigating seriously and documenting, with dedicated agencies, real budgets, and genuine scientific inquiry. The James Webb Space Telescope is right now, as of today, analyzing the atmospheres of planets around other stars, looking for the chemical footprints of biological processes. Enceladus is shooting liquid water into space from a warm ocean beneath its ice. We have a mission going to Europa to look at what actually lives there. And the honest scientific answer to can aliens exist is not, we don't know. The honest answer is, given what we now know about the size of the universe, the hardiness of life, the number of potential habitats, the burden of proof has actually shifted. It's no longer on the people asking whether life exists elsewhere. It's on anyone trying to argue that in a universe with more planets than grains of sand on each beach of the Earth, we are the only thing that ever happened. So, do we at Support Theory believe that aliens have visited our planet, or that the governments of the world, or even the United States government, have covered up their interaction with these beings? We wouldn't go that far. But what we can say is that the science is actually genuinely interesting. And this video was made purely because of that interest. The idea of life existing outside of us is a question that has plagued humanity for as long as we can remember, and one that will probably continue to be questioned into the distant future. But as science evolves and the more we observe, we get closer to the real answers every single day. Drop a comment and tell us what you think. After everything you just heard, what does your gut say? And tell us, what topic should we cover next? As always, guys, stay happy and stay safe.